Hello, everybody. In this video, I'm going to go through our lesson problem solving with similar figures. And the first thing I want us to do is to recall what is actually known as the polygon similarity postulate, which states that two polygons are similar if and only if all corresponding angles are congruent. And if all corresponding sides are proportional. Sides proportional. A key idea that kind of goes along with this is that congruent polygons, meaning polygons that are congruent, they are a special type of similar figure. Are a special type of similar figures. So let's kind of talk about the difference between congruence versus similarity. If two shapes are congruent, what does that mean? Versus if two shapes are similar. So congruent shapes, all sides, all corresponding sides and angles are congruent. So all corresponding parts are congruent. And congruent figures are created by rigid motions. Created by rigid motions. And our three types of rigid motions that we dealt with were translations, reflections, and rotations. Those are congruent figures. Now, if figures are similar, we have, that only angles, only corresponding angles are congruent. Well, I should say always congruent. And the sides might be proportional, right? So corresponding angles are always congruent, meaning that the sides are sometimes, not all the time, but they just need to be proportional. And this is created, similar figures are created by rigid motions, which, same three that we talked about here, and dilations, non-rigid motions. So if you've had rigid motions and non-rigid motions, that will produce similar figures. If you've only had rigid motions, then your figures will be congruent. Remember, those rigid motions are the three listed here: translations, reflections, and rotations. All right, so let's look at some examples. Oh, I did it in gray. Number 1, if triangle SRT is similar to triangle XYZ, the measure of angle R is equal to 45 degrees. Oops, 60 degrees. Wrong angle. So the measure of angle R is 60 degrees. The measure of angle Z is 45 degrees. What is the measure of angle Y? All right. So I really recommend that you draw this because it kind of might not make sense until you do. So we have two triangles that are similar. So I'm going to draw one triangle that'll look like this. Angles are not to scale, okay? Not to scale. And then I will draw the similar one. It's going to be just a little bit smaller. Okay. RST is similar to X corresponds to R, Y to S, and Z to T. Now let's fill in what we know. R is 60 degrees, and Z is 45. Our goal is to find the measure of angle Y. Now, since these two angles or triangles are similar, their angles are all congruent. So I know that angle R is congruent to angle X, since those two are corresponding, which means that angle X is also 60 degrees. So measure of angle X is 60. Now I have the two other angles besides angle Y in this triangle. So using the triangle sum theorem, I know then that 60 degrees plus 45 degrees plus whatever the measure of angle Y is, that has to be 180. So I'm just going to subtract 180 minus 60 minus 45 to get my measure of angle Y. And when I do that, I will learn the measure of angle Y is 75 degrees. Which means then that so is the measure of angle S. All right, number 2. In, oh, I don't need to say in. Quadrilateral JKLM is similar to quadrilateral. I'm just going to abbreviate this one. MNOP. If MJ is 59 degrees, or not 59 degrees, just 59, because this is a segment, JK is equal to 39, and PM is 16, find MN. All right, so I actually don't know what these quadrilaterals look like, so I'm going to make them kind of unique, I guess. So here's one of my quadrilaterals. I guess this is like a trapezoid. And then the similar figure, I'll make it bigger than the other one. All right, so I don't know if these are the exact same, but we'll call it close enough not to scale again. JKLM. So here's J, here is K, here is L, and here is M. That is similar to M, N, O, P. I just matching up each of the vertices. And I'm going to now write in everything that I know. MJ is 59, JK is 39, and PM is 16. Oh, it looks like it got smaller. So that's okay. I actually appreciate this opportunity to make the shapes look exactly the same. So I'm just going to take this one, copy it, and then resize it. I'm going to dilate it, if you will. And let's rename this MNOP. All right. We know PM. Our goal is to find MN, right? We don't know this MN. I am going to have to use proportions here, and I'm going to compare the big side lengths in comparison to the small side lengths. So the big side lengths that are corresponding to the small side lengths. MJ is one of the larger side lengths, and that corresponds to the smaller side length of PM. And I'm just going to write PM for now. JK is our other side length that we know. And the corresponding side to that would be MN, the one that we are trying to find. So I have the big sides on the top in relation to the corresponding smaller sides in the second shape. Now let's kind of fill in what we know. So MJ is 59. That will be over 16 because 59 turns into 16. And then 39, that is going to turn into whatever MN is. I'm just going to abbreviate that with an X because we don't know. And now I can solve. So I am simply going to cross multiply here. So I'm going to multiply 59 times X, and that is going to be equal to 16 times 39. So 59x, of course, is just, or 59 times x is just 59x. And 16 times 39, and let me make sure, is yes, 624. And I would definitely put that in my calculator to make sure. Now, to actually solve for x, I will have to divide both sides by this 59. So I'll divide both sides by 59. And I forgot to say we're supposed to round here. Find MN and round to a whole number. My apologies, because we're going to get a decimal. If I divide both sides by 59, they'll cancel on the left, leaving us with just x is equal to 624 divided by 59 is 10.576 dot, dot, dot. So this can be rounded to the nearest whole number. I don't want anything past the decimal, so I'm going to chop it off after the decimal, and the 5 is large enough to have us round that 10 up. So x here is approximately 11. Or the side length MN is approximately 11. All right. Number 3. This one has an image, so that's kind of nice. Triangle DCE is similar to triangle GFH. Find FH. Round to the nearest 10th. And our image here, if you can't print it out, go ahead and just kind of recreate it in your own notes. Whoa! And CDE, the triangle on the left, is similar to the one on the right. And notice that it looks like triangle CDE was kind of rotated and dilated a little bit. So let's kind of figure out what corresponds with what. It looks like this CE, this long side CE, would be corresponding to FH. So if I'm going to write the ratios here, I'm going to start with the small side length and relate that to the larger one. So 43, I am going to place over this side length FH that we don't know. And then I am going to relate corresponding side of 17 to its buddy GH, which is 58. So small sides over big sides, we don't know what this FH is, but it looks a lot larger than whatever this 43 is. So now I can solve for X, and just like we did in the last problem, I am going to cross multiply. So I'm going to multiply 43 times 58, and then I'm also going to multiply X times 17. Now, 43 times 58 is going to be 2,494, and that is equal to X times 17 is 17X. So to figure out what this side length X is, I can divide both sides by this 17. And when we divide both sides by 17, they will cancel on the right, telling us that X, which remember X was just FH, that is going to be 146.705 dot dot dot. So if I want to round this to the nearest tenth, that means I don't want anything past the 7 here, and the 0 does not tell us to round up. So really, I'm just going to say that FH is approximately 146.7 units. All right, we're going to do one more. Number 4. Find the perimeter of triangle IJK. And we're not going to round it or anything. We're just going to leave it as it is. And this has an image, of course, which you can recreate if you can't print it. All right, so I actually don't know anything about these two triangles. I see I have triangle FGH or FHG and then triangle IJK. So let's kind of start comparing these angles. So angle F is 74 degrees, and so is angle I. So angle F is congruent to angle I. Angle H is 55 degrees, and so is angle K. So those two are congruent. And lastly, angle G is 51 degrees, as is angle J. So those two are congruent. The side lengths, however, those are not. Those are not all the same. So I need to see if these side lengths are proportional here. I know the angles are congruent, so therefore, and actually, I could just say because these angles are congruent, that triangle FHG is similar to triangle IKJ. And then we can look at their side lengths and find that measure that we don't know, X. So we need this first. Solve for X first. And the side that corresponds to this JK is the side in between the angles 55 and 51, or the angle across, or the side across from the angle that is 74 degrees. So if I look from the side across the angle that's 74 degrees, I know then that HG and KJ, those are corresponding sides. And then I could potentially relate HF, which is 15, to KI, because both of these sides are across from the angle that's 51 degrees. And then I also know that FG is corresponding to IJ. So I need to pick two of these corresponding sides, two sets of them, and one of them should have the X. Now the ratios I'm going to write, I'm going to start with the small and put that on the top, and then I will put the larger value on the bottom. So I'm going to make sure I include that X. So I'm going to start by first saying, okay, 18, that turns into whatever this unknown side is, X. And also in our shape, I know that 15, that becomes 21. So I just pick one of the other corresponding sides, and then I use the side that's corresponding to X. Now I can solve for X. So I'm going to cross multiply here. We're going to multiply 18 times 21. And we're going to set that equal to X times 15, which is just 15X. Now 18 times 21 is going to be 378. So 378 is equal to 15X. And undoing that multiplication, I would divide both sides by 15, which tells me then that X is 25.2. 378 divided by 15 is 25.2. So let's see, let's put that right here. That is really side JK. If I want to find the perimeter of triangle IJK, like the problem asks us to, we need to add all three sides. So I need to add up 21 plus the side that's 22.4 plus the side that's 25.2. And when we do that, we add these sides together, we get a perimeter of 68.6. Please let me know what questions you have on this lesson. And this is our last one of the semester. Whoop, whoop. Let me know again what questions you have. I look forward to seeing you soon.